prime athlete who, in his elementary soccer team, he scored half of the goals for that team. He scored 1 out of 2. So, please welcome to the stage, Dr. Tom.
Awesome. Looks like my screen's up. So yeah, thanks so much for the intro there, Jared, and really excited to be here. I've always wanted to make it to New York R. Really excited to make it virtually, even though I wish I was eating pizza right now. So I'm going to be talking about a lot of different RMarkdown topics, really around kind of the strategy of using them beyond traditional data products. I really bit hard on this kind of Captain Marvel theme, so hopefully you enjoy that. If not, too bad. It's going to be there throughout. And if you want to follow along with my slides, you can reach them at bit.ly/MarvelRMD. So let's go to the next slide. So the reason why I kind of thought of Captain Marvel was A, it's a fantastic movie. I really enjoyed it and you should go watch it. But B, it really covers the idea of like the heroine's journey. And so I'll cover some of that here without any spoilers. So in Act 1, the story is set up, Carol Danvers here, all these different kind of difficulties she's facing. And along with that, here's the tool we're going to be using, RMarkdown. For Act 2 in the movie, complications arise. There's some betrayal and some difficulties, and we're going to be covering that as some problems with RMarkdown to be solved. And then Act 3, our heroine finds resolution, kind of wins the day. And so here's some solutions to those problems. But as we all know, coding itself is not a linear journey. So unlike a traditional hero or heroine's journey, which is kind of a very linear kind of path of going up and going down, coding is less about this kind of beginner, intermediate, expert, and more about finding and expanding your tool set for the right job at the right time. So some of these techniques you might use today, some of them might use down the road, but I think all of them are useful for many different stakeholders. The first kind of topic here for RMarkdown I'd like to cover is the idea of an RMarkdown taxonomy. So most people think of RMarkdown as kind of being one of these, when in reality it could be all of these together. So the idea of RMarkdown for literate programming, for data products, for control documents, and for templating. And I'll cover all of these throughout today's presentation. So the first one is literate programming, which most people are probably the most familiar with for RMarkdown. The goal here is to capture code, text about kind of what's going on or the analysis, along with comments and output, all in a single document. Literate programming was initially kind of coined by Donald Knuth. And again, it's the idea of mixing natural language such as English with snippets of macros or source code, which we can see here on the right. So RMarkdown is traditionally made up of a YAML header, which kind of defines the structure of the document, code chunks that execute R code or other kind of language engines that are available in Literate and RMarkdown, and then text, which can still have inline code, but is primarily about prose or kind of talking about what the code is doing or output. And you can intersperse these all together, kind of taking natural language and source code natural language throughout the document. So in addition to being just good for literate programming and mixing code, RMarkdown is also the MVP of reproducibility. So this can mean the minimum viable product in terms of you have your output as self-documenting and you have code that's embedded together, or it's the kind of the most valuable player. So it's able to kind of help you guide to this journey of reproducibility. So RMarkdown has to run successfully to save or knit the output. So if you do have errors, you can't kind of produce a faulty output. And importantly, it's diffable and human readable in version control. So if you check it into Git or something like that, you can parse through it very easily in source and version control. A quick example of what I really enjoy for using RMarkdown for literate programming is covered by both Dave Robinson and Julia Silg, who most people attending this conference are pretty already familiar with. But they do Tidy Tuesday screencasts, usually weekly, and they use RMarkdown to control kind of the programming and code that they're doing, along with text output or kind of structuring their document. So I recommend watching some of their videos or looking at that for an example of literate programming. Importantly, though, when you think of literate programming, we always think of RMarkdown, but it's not just for R. You could actually run Python code natively or call Python from R with Reticulate. You could run entire SQL chunks to run native SQL code from R, or kind of pass it back and forth. You could do front-end scripting with CSS or JavaScript or add little HTML chunks. And along with that, there's a total of 52 possible language engines for things like Bash, RCPP, Stan, or many other languages. So this reproducible document with all sorts of different code chunks interspersed with text. But enough about Literate programming. So that's kind of somewhere where everyone knows about. Data products are also something that people probably are pretty familiar with RMarkdown. And the idea here is that you're using R to generate a final output for consumption. While you still want to be able to control the source code to kind of make it reproducible, here you're generating graphics or reports or something to kind of digest some type of data. So the most common data products are things like reports, presentations, entire dashboards, full-blown websites or blogs, books, and one of the kind of underutilized things I think with all of these data products is the idea of HTML widgets. So for all these, I kind of went through quickly. Again, I think people are familiar with that. I added links to them. But for HTML widgets, again, there's things like DT, Reactable, Plotly, Crosstalk, and many more that allow you to get somewhat of a Shiny-esque experience without having to have a server backend. And I'll show you a quick example here. So here I have a basic RMarkdown doc. It's got a YAML header and a code chunk to set up some different libraries I'm using. We read in a data set from the Palmer Penguins data set, assign it as a shared data frame. What this means is it's sharing data across multiple HTML widgets, which are basically JavaScript libraries you can call from R. So I'm going to use Plotly for the interactive graphic and then Reactable for reactive table, both of which are being fed the same shared data set. I can then do a code chunk that builds a little bit of a GUI interface. So I got some filters for checkboxes and sliders, and then I call my my graphic and my table. And what this looks like in practice is, I get my video to load. So this probably looks like Shiny to you in terms of you've got these little selectors, it's affecting the data, both the graphic and the table are kind of reacting to changes I'm making with changing the sex, changing the species, or filtering the body mass. But importantly, I could literally like email this to somebody that could open up and use it. I don't have to have a server backend. I could still use it with Shiny, and you can do it that way, but any HTML output can use HTML widgets in this way. So we covered data products, we covered literate programming. I went through those pretty quickly because, again, I think a lot of people, that's what they think about for RMarkdown, and I'm trying to expand into the idea of RMarkdown beyond those things. So the idea of a control document is that your goal here is to modularize data science tasks or use RMarkdown to control your overall code flow. I'll pause here for a second and talk about somebody else's presentation. So this RMarkdown-driven development was put together by Emily Reuterer, who has put a lot of effort into the idea of like productionizing RMarkdown and the use of it in enterprises. So here she has some modularized chunks that she's using where she's sourcing either functions or from an R package. She's got a folder structure with final reports, data, documentation, other external files, and ends up with this nice, clean, polished RMarkdown that generates and pulls in data and performs an analysis. I'd really recommend checking out her blog post or her video on the same topic. And I'll be proposing a few ideas that could fit into this kind of worldview of using RMarkdown in a production setting. So the first idea for using RMarkdown as a control document is the idea of params or parameterized RMarkdown. So here we add a special YAML header. So within the YAML, we have params, and then we're providing a species argument that's assigned addli, which is one of the penguin species present in the Palmer Penguins data set. So I can reference this specific parameter anywhere within the RMarkdown doc. So I can reference it in code with params $species, or in line with backtick R params $species backtick. So whether you're using it in a code chunk or in line, you can kind of get whatever this output is and put it into your document. So when I knit this, it's going to feed in addli and replace those and actually generate a nice report for me. We have data about all these different penguins. However, for the addli penguins, we only have 198. And here's a quick histogram of those. So kind of a basic example, but I wanted to focus here again on the idea of specific things you're doing to RMarkdown rather than these complex reports. You can also reference external R files. So for params, we're referencing it within a document. What if you had code you're trying to pull in from elsewhere? You can always source it, and that will pull in a function. But here we can actually pull in entire code chunks from an external .r file. So we read a chunk, penguins.r, which is seen here on the right, and we can reference these code chunks by name. So this code chunk is actually empty, and I'm just saying smaller penguins. This code chunk is also empty, and I'm pulling in plot penguins. I'm actually pulling in all the code that gets executed in here from these labeled blocks of code from a .r file. So I have, this smaller to define the data set of interest, and this graphic that I'm recreating. So I can recreate my previous report without having to use parameters and using external R code. You can also use the idea of external RMarkdown documents. So within a parent RMarkdown document, which is kind of your overall control structure, so this penguins here is the parent document, I can actually tell it, use this child report, which is adeli.report.rmd, seen here on the left. So for here, again, we have an empty code chunk, but it's going to execute all of the code within this report. So it'll pull in, again, our smaller things, some prose and text that's executed with inline code, and then another code chunk to generate a histogram. So this is pretty fancy. I mean, you could have a very lightweight parent RMarkdown and have all sorts of other different .r files or RMD files that are external, and then you can modularize a report in this way. Child documents also have the benefit of being able to do logic or conditional statements. So again, we have the same child report, but now I've created a logical statement based around the species select. I'm saying species select is equal to chinstrap, which is yet another species of penguin from the Palmer's penguins data set. So here, the child document is only executed if this specific variable is equal to adeli. Since it doesn't, and it equals chinstrap, it actually generates a blank report. However, if this was equal to chinstrap, then it would generate the chinstrap data set. So you can imagine here that you're sourcing external R files, and based upon some parameter you're setting from data, basically you read in data and perform some analysis, it pulls in a specific report and runs that inline as needed. Another one, so these have all been the idea of pulling R code into a parent document and executing it. Kind of doing it the other way is taking a parent document and creating child reports. So blast emails are essentially a child report that gets sent by email. So here I'm creating a penguins plot and a penguins report. So it runs for our markdown. But here at the very bottom, I'm actually generating, creating, and sending an email through RStudio Connect. So here the input is this penguin email.rmd, which again can use empty code chunks because I'm referencing existing shared basically code chunks between the two documents. So in the parent document, I have penguin plot, and I can call that without any code by just using the same name. And this will generate a full email. So it'll generate this specific HTML formatted email with a ggplot inline in your inbox. And you could run this through RStudio Connect or through Gmail or through, I think, a couple other different SMTP email servers. So again, the idea of parent to child. While we're talking about RStudio Connect with the idea of control documents, our Markdown documents can be scheduled through Connect to do all sorts of really cool things. So you could do self-service parameterized R Markdown for non-tech users. You can imagine, I as an R user can do parameterized R Markdown. It's very powerful. If I give that to someone who doesn't know what R is, they're like, what the heck is this? How do I use it? So you could provide them a GUI interface through Connect. You'd also schedule ETL scripts, so things from SQL, web APIs, or Spark, for example, and run those out. You'd also do automated reports with full logging and history, so kind of different versions of the same report all captured in one spot. The other part that a lot of my colleagues use is for long model training steps. So you have like a 2-hour training step for this giant random forest. You can run it overnight and have it save the model out to a database or to a flat file somewhere. And lastly, again, you could send blast emails conditionally or on a specific schedule. So if this parameter is hit, then send an email to these people. Cool. So we covered a lot of different control flows there, which is very exciting. For the last part of the presentation, I'm going to be talking about the idea of templating. So here people might think of templating as different themes, but I'm actually talking about different reports from the same code. So here the goal is don't repeat yourself, generate either input templates or output documents from code. And this could be, again, R or other different languages supported by R Markdown. We talked about parameters and parameterized R Markdown. So this is the same report as previously. But now I can programmatically generate this report. So rather than having to click knit in RStudio or elsewhere, I could go at the R console and say, render this specific report with the species equal to gen2. And now we've generated a brand new report from the same existing code. And we could do this for each of the different species in the penguins data set. You can also generate mini reports all at once. So the idea of rendering with parameters plus a for loop, or maybe per map or per walk to generate multiple reports. So here I'm finding all the unique different types of penguin species, looping through and generating a report for each of them with the name ahead of their report. I can do the same exact thing with per walk, but with a function instead of a for loop. And now I can see I have 3 reports, one for Adelaide, one for Chinstrap, one for Gen2, all named correctly, all generated at the exact same time, all with one kind of execution of code. So you can imagine generating hundreds or thousands of reports all at once from a similar code and just changing the parameters. And again, these parameters could be, you could have 10 different types of parameters. It doesn't have to be just one. On the other end of the spectrum, rather than generating multiple output files, often you may want to generate multiple repeats within the same document. So rather than generating like copy, paste different code chunks, you can actually re-execute a code chunk in a loop or with map as well. So here I have a similar report. I'm actually sourcing an external R file called multiplot, which is pasting together some text. It's doing some filters and summarization. It generates some raw text about the data set that I'm using, creates a graphic, and then adds some blank space. Importantly, for this code chunk, I'm using results equal as is, meaning that whatever the results spit out, Knitter and RMarkdown will actually parse through those and re-execute the output. So it's kind of weird to think about, but you're basically knitting this part, it executes the code, generates more stuff, which is then executed for the final output. So here, rather than creating separate reports, I'm able to create a similar kind of structured report within a single document. So Adelaide and Gen2 and the observations and their flipper length, and then a different graphic for each of them. And again, this could be hundreds of different things all done in line, or just a few as I've shown here. Now, I was using glue to actually paste together some things, but I think it's important to differentiate between the idea of glue and other things like Whisker. When we think of Whisker versus glue, the answer is 1 versus 2. So glue uses these parentheses within a text or within a character string, and it replaces whatever is inside these with either R code or a variable name. So there are 32 rows in the mtcars data set. We can do something similar with Whisker render, but now we're using 2 parentheses rather than a single parentheses. When I think of glue versus Whisker, really the idea is glue is something I'd use in line with our code or maybe within a data frame. Whisker is something that I use much more commonly with raw text files. So for something like the Tidy project, every week I have to generate a pretty standard README. So I could copy paste this and kind of change things out, which I've done in the past. But recently I've switched this over to use Tidy Tuesday README, which is a function that actually pulls in a .md file, parses through all of it, puts in the correct date, puts in the correct URL and the dataset name, and then fills it up with Whisker, and then writes it back out as a README template I can then post onto GitHub. So for here, my Whisker output, I can see the different data, and this is what the output looks like. I have the date, the year and the week, the name of the data set, and all this was filled programmatically by my function. That was a README file, so that's exciting, that's raw text, but you could also do this with RMarkdown. So here I have a template, which is this Whisker input, which has double backticks in a couple places, so species and long prose. And actually you can fill this raw text file, this .rmd file, with new things with code. So I can replace this with Adelaide, and this long text chunk, and then I can start working with this output document and continue adding text to it. So this is really powerful because I am able to reuse the same document and continue typing it up rather than having to rely on doing it all with code. Often you generate a report and you need to add a few things to it. And so that's really the power of Whisker, is you can write it back out to a raw .rmd file. And this is what the function looks like. It basically just reads it in, fills it, pastes the different name out so that you're not rewriting over the same document. I'm just adding the different species, the long prose, and calling it with species and long prose for my template. So a one-liner, which is really powerful. Use template also has the similar idea, but you're working off kind of the use this package, which allows you to provide a template. I wrote mine by hand, but you could also use this in a similar way. So that's it. I covered a lot of different things. You have the power, and I hope that now you can use some of it, and it's interesting to you. There's some follow-up reading here for a few different blog posts, including mine. And again, the slides are up at bit.ly RMarkdown.
Great. Thank you so much. So before we get to our next speaker, we've been giving away books this whole time.